All right, so we just calculated all these expected values from our observed tables. So now we need to actually think about our test statistic. And as we discussed, it's going to be what we call the chi-square statistic. What it's going to do is it's going to sum the square differences between the observed values and the expected values. So what we're going to do is for every cell, we're going to take the observed value. Let me clean this up. We're going to take the observed value, subtract the corresponding expected value. We're going to square that difference, and then we're going to divide by the expected value. And we're going to do that for all of our cells, and then we're going to add all of those up. That number is going to be our test statistic, which we call the chi-square statistic. So let's talk about some of the assumptions for this to be valid. So our assumptions, and the first is that we need independence. So independence of populations or samples. So the responses in, say, one category, so for Palm Royale, should be unaffected by the responses by Golden Palm. Now, if all of these if there are no customers who went to both, that's like a reasonable assumption. But if you had some customers who have been to both hotels, we might say they're actually not independent. But let's just assume that we have a non-overlapping group of people. And then the second is that the expected frequencies are all at least 5. So all expected frequencies are at least 5. And we can check that real quick. All we need to do is look at this expected table. Are all of these bigger than 5? And yes, they are very clearly bigger than 5. So we're going to be good to go here. So let's go and return to our example. So let's go ahead and calculate this chi-square. So we have, let me copy and paste that down. I don't want to rewrite it. Okay. So we want to calculate this value. So equals. So what we're going to do is we're going to take every expected value, or every observed value. So let's start with yes, Golden Palm. So this would be 128 minus its expected value of 158.3. We're going to square that difference, and then we divide by expected, which is 158.3. And then we're going to add. So let me just make this clear. So we're going to take our observed frequency. So for Golden Palm and yes, that's 128. So 128. We're going to subtract off the expected value first. So for yes, Golden Palm, the expected value is 158. So I have 158 here. Then we squared that difference. So square, square. And then we divide by the expected value. And we just said the expected value is 158. So I'm going to divide by 158. This symbol means to sum, so that's why I'm summing here. And now we're ready to move on to the next cell, which is going to be yes, Palm Royale, so that this number. So let's go ahead and do that. So now we're going to do yes, Palm Royale. So we have 199 for our observed minus 170.02 for expected. We square that, divide by expected. That's 170.02 plus yes, Palm Princess. I have 186 minus 184.68. We square that difference, and then we divide by expected, 184.68 plus. All right, so now let's move on to the second row. We're now going to look at no's. So look at no's across the board. So let's start with Golden Palm. So this is going to be 88 minus 57.7. We square that and divide by expected, which is 57.7 plus. So Palm Royale, 33 minus 61.98. Divide by 61.98, and we square that. Plus, finally, 66. So this is Palm Princess. No, 66 minus 67.32. squared over 67.32. So you do these, and then you add all of them up, and you should get a value of about 40.23. So that means chi-squared is equal to, and actually maybe I should be more specific because this is our calculated value, chi-squared stat is equal to 40.23. And then let's just quickly check our assumptions, and we already kind of did this. So 1, independence. And we said yes, like we said, when someone's response shouldn't be affected by another hotel. Of course, they went to both hotels, then this assumption would be violated. But if you only went to one out of the three, this should be fine. And then the second assumption is just all expected counts greater than or equal to 5, and that is true. Every value, these 6 values are all bigger than 5, therefore that assumption is met.